Okay, so given a simply linked list, rotate the linked list counterclockwise by k nodes, where k is a given positive integer smaller than or equal to the length of the linked list. For example, if the given linked list is this, and k is 4, the list should be modified to this. So essentially what we've done is move the starting point by 4 spaces, right? So 1, 2, 3, 4. 50 is the new starting point, so 50, 60, and the rest of the list, this connection is broken, and 50, 60 is linked to 10, 20, 30, 40. Let me check on the recording. Okay, it's still going. Perfect. Using some new tech. All right. I will start with the function definition. And this is going to accept a simply linked list called list using the definition I showed in the video for question 1, and it'll also accept an integer k. Now I'm going to store some variables to keep track of. I'll initialize all of them to the head of the list. And an integer count to keep track of how many rotations we've done. Because we need to do k single counterclockwise rotations, right? So, wow. Current.next is not null. And we were also given where k is a positive integer smaller than or equal to the length of the linked list. So, yeah, we won't run into any issues with that. Increment count. If count is k, if we've done k count, if we've done k single counterclockwise rotations, that's a mouthful. Assign the current node to kth. Here we advance current. If current next is null, and we know we've reached the end of the list. So last is current. Amazing. Okay, outside of this while loop, I will connect last to the head of the list. So now it'll be a circular linked list. I will also replace the head with its new starting point. So yeah, I'll replace the head with its new starting point. The new starting point is going to be the node that comes right after k. And yeah, that's what I need. Oh, return. That's funny. Yeah, I need to actually return something here. Return list. Alright, let's take an example. So the linked list we're given is 1, 2, and 3, which points to null. And we're given that k is, let's say k is 2. Make it a little bit interesting. Okay, so first thing we do, current.next is not null. 1 is, okay, let's put all these in here. So count is incremented right away. If count equals k, it does not. Current is current.next, so current is reassigned as value 2. If current.next is null, it is not. Continue in the while loop. While current.next is not null, that's true. 2 is currently current, right? Count plus plus. So now count is 2. If count is k, yes, 2 is 2. Then kth is current. So now kth is 2. Current is current.next. Current is updated to 3. If current.next is null, that's true. Last is now current. So last is now 3. Amazing. Current.next is null, so we're out of the while loop. Excuse me. Last.next is assigned as the last.next. Okay. Last.next is assigned oh, okay. I don't need to I tripped myself up for a second. Here I'm connecting last to the head, so now we have a circular linked list. The new head is kth.next. So kth is currently 2. 3 is the new head. So now I need to, I missed something. I need to break this linked list. It can't stay circular, right? So kth.next needs to be assigned as null. So what we have right now is the head is kth.next. Kth is 2, kth.next is 3. So the head is 3. We already said it wrapped around, right? So this wrapped around to here. So 3, 1, 2, and then the final step, I assign kth.next to null, and this is the desired output. So regarding time complexity and space complexity, time complexity is big O of n, or linear, and space complexity is constant, big O of 1. Because we're only looping over all the elements once and not using any extra space.